Hello everyone, welcome to Chip Confessions. In this session, we will see what is array data type. So till now, we have seen many kind of data types in Verilog, and this is array data type. First, let us know what is an array. Array means nothing but a series of some objects or series of anything. Array means something in series. What does this array data type do, or why we have this array data type? We have already reg data type, we have wire data type, we have integer, untime, real, we have everything. Then why we need array? Let us consider an example in which, this is just general example I am taking. We have this page number 1 and this is don't worry about the size actually, and yes, this is page n. So we have page 1, page 2 and page n can be anything. These are the pages we have separate, like P1 is one page, P2 is one page, and PEN means it can be any number of pages we can be having. So if we want to keep this separate, there will be, like, for example, say if n is 100, so total number of pages will be 100, and 100 separate pages we will be having, and maintaining will be very difficult, right? So what we can do, we take from page 1 and till page 100 or page n, and we will bind them. Bind them means what this will become? This will become a book. So while we are taking all the pages and we are consolidating them and making, and we are joining them and making into a book. So what is a book? A book is nothing but collection of so many pages. Same thing applies to an array. You have some variable and that variable is of reg type. Variable is of reg type, let the variable be a, and this a should hold, say, some 10 values. It will be like, we can't give reg a1, reg a2 and then reg a3, like that. If we keep on going, it will become like reg 10, sorry, reg a10. So how many variables we have got? We have got from reg 1 to reg 10, we have got 10 variables. So this is simply increasing the number of variables. Instead of that, what we can do is, we can take array of reg data type and assign with 10 locations of memory, 10 memory locations, and then store 10 data, which is easier to just think, taking 10 different variables and assigning 10 different values to each of the variable, or grouping everything, means grouping all the memory locations and naming it with a single name, and we will be able to access that memory location with a single name. Only thing, we just have to give the memory location some index, that we will see. But when compared to this, when we have multiple values to store, when compared to this is more manageable, and this is more handy and more readable also. Who will remember 10 different kinds of variable? You just tell me. It is not possible, right? When you have hundreds of locations or Say for example we have memory. In memory we will be having, if you have 512 GB of memory, 512 GB locations will be there. Can you like A1, A2, A3, A4 like that, can we give till 8 512 GB? No, right? It's not possible. Yes, it's ideal condition, but still, yes, it's possible, but it's very ideal condition, and it's like very less efficient kind of thing, means not at all efficient. So that is where array comes into help. What is an array? Now if we see what is an array, array is nothing but, yeah, okay, array is nothing but a group of homogeneous elements. Group of homogeneous elements. Let us see one by one. We got to know what is group. Array means group of homogeneous elements. This group we got to know. What is group? We are taking so many number of values and we are making it into one. This is called group. We have so many values here and we are grouping it as one. This is what group is. What is this homogeneous? This homogeneous means same type. Means if we have integer, whole array should contain this integer values only. You can't take like here integer and here real, here reg, here wire. You can't take like that. So homogeneous means it should be of the same type or same data type. I'll just give you a funny example here. You all know train, right? We have got train, and let's say this is the engine of the train. So this is the engine, and okay, let us say this train is moving in the left direction, like this it is moving. Okay, like this it is moving. So we have coach number 1 here, coach number 2 here, this is coach number 1, this is coach number 2, this is coach number 3. Like this, we will be having some n number of coaches, say some 30 coaches, 40 coaches, like that. So this is what train is, and all these coaches will be identical with this train. Means every coach will be looking similar, or they will be similar kind of coaches. Inside, okay, it can contain 3AC, 2AC, 1AC, first class, sleeper class, anything, but these coaches will be similar. Let us imagine another condition where we have a engine here, train engine, and then here we have a bus. And here we have a car, here we have a bike, and here we have some lorry. I know it's funny, but still, just imagine a train with normal coaches, with driven by an engine, and with normal coaches, and the train driven by an engine, but instead of normal coaches we have a bus, a car, a bike, a lorry. Do you think it can be driven by that engine? No, right? Yes, it's really funny, but still, yes, it cannot be possible. Same thing you can think of the arrays. Array is nothing but like a train, a group of homogeneous element or a collection of homogeneous elements. Means each value is called as an element of an array. Like each coach we have here is a bogie or coach, what we call for this train. These values will be called as element of an array. So what is an array? An array is a group of or collection of homogeneous elements. Can we have different things? No, it's not possible in Verilog. It is possible in System Verilog, that with the help of we have class, we have structures, we have unions, we have. In structure and union it is possible actually, but not up to the class extent. But in arrays it is not at all possible to have different kinds of elements. I mean elements with different data types is not possible in Verilog arrays. So now let us see the declaration of an array. So before that we should know two things, that is packed and unpacked. These two are the important keywords in arrays. Means what does, these are the types of the arrays we have. What is a packed array, what is an unpacked array, we should see. Let us take an example. We have an array like this and it is divided like this. I'm bad at this lines, so okay, like this we have some array. Okay, and we have another array which is like this. It can be separate also actually, or this can be depicted as like this. Both can be possible, like this. Okay, so we will be, now we have two kinds of arrays here, and here what is happening in a single way, means in a group which is seen as a single group. If we are storing some elements, then this is called as packed array. Means everything is packed, nothing is separate here, everything is packed. So this is called as packed array. Means this will be contiguous allocation will be there, means in between no gap will be there. It will not be like 2 I have given, let me take 4 gap, again 2 I will give, and again 4 gap I will give. No, it's not like that. This memory allocation will be continuous. It will be like this. Continuous set of allocation of memory will happen if it is packed. So it is called as packed. It will be like totally, if you are packing something, you are keeping in adjacent way, one after the other you are keeping, and you are packing something, then that will become packed array. What is unpacked array? In unpacked array, even though it is a continuous location, it will not be like this. Means this is separate memory, this is separate, this is separate, this is separate, or it can be like this also. This can be separate, this can be separate, this can be separate. So the best way to see this is, whenever we have, usually in systems the registers will be of 32-bit type. Okay, 32-bit registers are the most common registers we have, and whenever you are declaring an array like this, these registers will be used efficiently. Means memory wastage will, or locations wastage will not happen. Like this it will be in packed array kind of declaration. So there will be no sparse or no wastage of memory. Means if you are declaring like 31 down to 0, or if you are declaring like complete 32 bits, there will be no wastage. If you are declaring like 4 bits or 5 bits, that much will be allocated and rest of the things will be empty. But whenever we are declaring an unpacked array, what happens is, like this we have something, and we have to say we have 10 elements in that array we are declaring, and each element is of 1 bit. So see, this bit will be allotted, this bit will be allotted, this bit will be allotted, this bit will be allotted like that in 10 registers, 10 single bit will be allotted. So how many wastage or how many empty spaces we are seeing here, right? So this is not possible, or this much empty spaces cannot be possible when it is packed array. When it is an unpacked array, this parse or this empty locations can be possible. But it's not like based on the application we will be choosing which kind of array we have to use. It's not like array will memory location will be wasted every time I should take packed array. No, it's not like that. You can take any kind of array, you can declare any kind of array. Both are the both possibilities are there based on the application. It's like that. So now we saw how this packed and unpacked array elements are stored in the memory. Now let us see how we can declare them. Basic thing is, first we have to give the data type. Let us take it as reg for example. So or else we have to give the data type here. Then if we have to give something called as width, if it is a packed array, and name of the array. This is the array or this is the array name. This is how you have to do when you are declaring a packed array. So this is for packed array. Whenever you are declaring an unpacked array, what you have to do is you have to give the data type, then you have to take the name of the array, and then you have to give the size or the number of elements that this array holds inside this square brackets after the array name. This is the difference we have. In packed array, what we will do, we will take data type first, then we will declare something called as width and the name of the array. This is width is nothing but the size, actually horizontal size. This is the vertical size, horizontal size, and then we will give the array name. Then with the unpacked array, what we will do, data type is common and we are taking the name of the array here, then we will be giving the size. This is the only difference while declaring these two kinds of arrays. Okay, then what we can do is, can we combine both? Yes, we can combine. How to do that? We have to take the data type and then we have to take the width and then we have to take the name, then size. Done. It's very simple. We have to take the data type, we have to take the width, and then we have to take the name of the array, then we have to give the size. This will combine both packed and unpacked array. How it will be stored? It will be stored, for example, you have taken 10 bits of width with size 10. Then what will happen? 10 bits will be allocated like this. 10 bits will be allocated like this, whole 10 bits, and then to 10 location. Each location will have 10 bits, 10 bits, 10 bits, 10 bits, 10 bits. It will be like this till location 10, means 10 locations. It is like this. So revising everything, packed array means it is like horizontal width we are giving, and packed means because there will be no space in between or no wastage of memory until there is a end of the size. After the end of the size, yes, there may be some space depending on the size of the or width of the element, but still usually there won't be any space in between the bits. But here in unpacked array, what happens? Everything is a separate memory. So there may be situations where that kind of sparse or empty locations can happen. How to declare both? While declaring the packed array, we have to give the data type, width, and then we have to give the array name. For unpacked array, we have to give the data type and then name of the array, and then we have to give the size. While combining both packed and unpacked arrays, we can give the data type, then mentioning the width and the name of the array, and then size we can mention here. Let us take an example of all these things. Let us see how we can give the width. Width means it is like we have to mention it in between the square brackets, and then what we have to mention here is it should be like either 3 down to 0, like that you have to give. Means 3 down to 0 means you are giving in such a way that you have location 3, location 2, location 1, location 0. It can happen in reverse way also, like you can give 0 2 3, then it will be like reverse 0 1 2 3, like that it will be. Means it is just a depiction, it is just a depiction. That how the elements are arranged and all that we will see when we go to coding. You just need to understand how we can declare the width. Usually what we will do, we will take the larger number in the left side and smaller number in the right side, and that is the convention we follow. Like this it will go, and that is the convention we follow, because usually MSB will be the highest number and LSB will be the lowest number in the conventional use. So we will declare like that only. Okay, so usually whenever we are declaring the width, we will take the highest number first and then we will take the lowest number. It is not like you need to take 0 only always. No, you can take, instead of, see, in 3 down to 0 what happens, 3 2 1 0, like 4 locations will be allocated. Like that, if you take 4 down to 1, in 4 down to 1 also same thing, 4 locations will be allocated. Like how, 4 3 2 and 1, like this 4 locations will be allocated when it is coming to 4 down to 1. So you can give any of the number. If you want 10 locations, you can give like 11 to 19, or sorry, 19 to 11, like that you can give anything. Only thing what you have to know is these numbers will be inclusive and these numbers will be the index numbers. Whenever you are accessing that element, you have to use this number as a index. Like example we will take, I will take like I have reg and I will give 3 down to 0 and I will give A. How I can access it? When I am accessing 0th element, I should give A of 0, and whenever I am accessing first element, I should give A of 1, A of 2 or A of 3, like that I should give. This is A of 2 and then A of 3, like that we have to give while accessing the array elements. What if it is like, as I said before, what if it is reg 4 down to 1, in this same thing, like we are giving A of 4, A of 4 will be your MSB, A of 3, A of 2, A of 1, A of 1 will be your LSB. So this is giving the name to your element location, means for individual location this number will be given as the name of the index of that particular location of your array element. Then how we can declare unpacked array? How we can declare unpacked array means, as I said, we have to give the data type, then data type and then name of the array, and then we have to give the size. For example, let us consider, let the size be 5 here, let us take a smaller number. So here also same thing. And one difference what we can see here is the way we are declaring here, it should be always like this, down to only we have to give. And here we have to give we can give a complete number or we can give a declaration like this. This is called as compact and verbose declaration that we will do. And whenever we are declaring for a unpacked array, we can declare it in any way. Like we are declaring it reg array name means data type array name. We can do like this. This will take 10 locations, or if we do 9 down to 0, this will also take 10 locations inclusive of both the numbers. Or we can do like this, rich array, we can give 10. Both or same, both or same. Only thing is, you are just telling how the location has to be accessed. It will be like this. This will be 9, 8, 7, 6, like this. But when it is 10, you are telling it is 0, 1, 2 till 9. It will be like this. So this is how we declare the arrays. So let me end the session here. In the next session we will see how we can iterate through the arrays, and how we can assign the values, and how we can do any array operations and all. So thank you for being with me in this video, and then I apologize for not uploading the sessions because I was quite busy these days, but I make sure that at least one session, minimum to 15 to 20 minutes of session, I will upload every day. At least I will try to cover one topic. That I can tell, I can assure that, even though I can't promise, but I can assure that. Yes, I really understand that your time is also important. I should not delay from my side, but yes, apologies for that. And from now onwards, I try myself to I try my best to upload the videos daily. Thank you so much. Thank you for being with me in this video, and please like, share this video and hit the subscribe button so that you will not miss any updates in the future. Thank you so much.